So in today's video, we are going to do further simplification of a force and couple system in 2 dimensions. We shall be solving 2 questions, and this happens to be our first question. So question 1, we are going to replace the loading system by an equivalent resultant force and specify where the resultant's line of action intersects the member measured from A. Now the first thing we are going to do is to find the equivalent resultant force, and then next we are going to specify a distance, say D, away from A, where the resultant's line of action passes through. So first of all, let's assume that we have F1 to be 20 kilonewtons. So the first thing is to label the forces. So F1 equals 20 kilonewtons, and then we have F2 to be equal to 15 kilonewtons. Now F1 acts vertically downwards, so we can say that it has only a y component, that's F1y equals negative 20 kilonewtons, and then F2 has both x and y components, so we have this to be the x component, F2x, and then this to be the y component, F2y. So F2x is nothing but F2x corresponds to 4, so we are going to have 4 divided by 5 times the hypotenuse, which is 15 kilonewtons. So 5 goes here once, 5 goes here 3 times, 4 times 3 is 12. So we have 12 kilonewtons for F2x, and then for F2y, still using the small slope triangle, F2y corresponds to 3. So that becomes 3 over 5 times 15, and that is equal to 9 kilonewtons. So next, let's find the sum of forces along the x-axis. So we have that to be Frx, and that is equal to 12 kilonewtons. And then for Fry, that is equal to, we have the value for F1y, which is negative 20, plus F2y, which is 9, and so we have this to be negative 11 kilonewtons. Therefore, we can find Fr as the square root of 12 square plus negative 11 square, and when you evaluate this, you are going to get 16.3 kilonewtons. So that is the value of the resultant force. Now let's find the angle theta. So the angle theta is given by tan inverse of Fry over Frx, neglecting all negatives. So that is equal to tan inverse of Fry is given as negative 11. So we neglect negative, and then we have 11 divided by Frx, that is 12. So tan inverse of 11 over 12 is equal to 42.5 degrees. So this is the value of theta. Now let's draw the resultant force with its x and y components somewhere here. So we have Frx to be a positive value, so it is moving along the positive x-axis, and then we have Fry to be a negative value, so that is also moving along the negative y-axis. So we have the resultant force somewhere here, that is Fr, and this is the angle theta. Now we are going to use this later in our solution. Now we've been able to find the equivalent resultant force, that is Fr. The next thing we are going to do is to specify a distance away from A, where the line of action of the resultant force intersects the member measured from A. So in doing that, we are going to find the moment of each of the forces given in the question about A and then sum them up. And then we equate that to the moment of the resultant force about A. So first of all, let's find the moment of all the forces or all the individual forces given in the question about A and then sum them up. So that is given as the summation of moments about A. So the sum of all the moments given in the question about A. So that is equal to, so basically we are going to consider the forces 20 kilonewtons F2y, which is given as 9 kilonewtons, and then F2x, which is also given as 12 kilonewtons. So let's do this together. So starting from 20 kilonewtons, taking the moment in the clockwise direction, we are going to have a perpendicular distance of 2 meters away from A. So that becomes 20, and since we are moving in the clockwise direction, then this value still becomes positive. So 20 times 2. Then we move on to F2y. Now F2y is going to move in the anticlockwise direction. It has a perpendicular distance of 6 meters away from A. Therefore, since it is moving in the anticlockwise direction, it becomes negative. So negative 9 times perpendicular distance 6 meters. Also for F2x, we have this to be the perpendicular distance away from the line of action of A. So we are going to move in the clockwise direction, and that it becomes positive. So we have 12 times perpendicular distance 2 meters. Now let's evaluate this. So we are going to have 20 times 2, that is going to give us 40. So we have 40 minus 9 times 6 is 54 plus 12 times 2 is 24. So we have 40 plus 24, which is 64, minus 54, and that is equal to 10. So this is equal to 10 kilonewton meter. Next, we are going to find the moment of the resultant force about A. So in doing this, we are just going to specify any arbitrary distance, say D. We are going to specify any arbitrary distance, say D, away from A. And at this point, we are going to have the resultant force, that is Fr. Now, this Fr has a positive x value and a negative y value. So we are going to have something like this. That is Frx. And then we have this to be Fry. And then we have this to be Fr. Now, we are going to take the moment of Fry and then Frx about A. Now, since the line of action of Frx passes through A, what this primarily means is that the moment about A is equal to 0. So let's focus on Fry. So for Fry, we are going to take the clockwise direction. It's going to move in the clockwise direction. And we have the perpendicular distance to be D. Therefore, we have the moment or the resultant moment about A is equal to, we have Fry times D. Now Fry is equal to 11 kilonewtons. We are going to consider this as a positive value. Okay, so since we are moving in the clockwise direction, it still remains positive. So we are going to have 11 times D. Next, we are going to equate summation of MA to MR of A. So we are going to have MR of A equals summation of MA. So that is 11D equals 10. Now we divide through by 11, and then we have D to be equal to 0.909 meters. So this happens to be the distance where the resultant force line of action intersects the member measured from A. Now let's try the next question. Question 2. We are going to replace the loading system by an equivalent resultant force and specify where the resultant's line of action intersects the member AB measured from A. So as usual, we are first of all going to label the forces. So we have this to be F1. F1 is equal to 8 kilonewtons. We have F2, 6 kilonewtons. F3, 5 kilonewtons. Now, F1 is acting along the x-axis, that is along the negative x-axis. So it's going to be negative. So we have F1x because it has only an x component and then acting along the negative x-axis. So F1x is equal to negative 8 kilonewtons. Now for F2, it is acting vertically downwards, which means that it has only a y component. So that becomes F2y, and that is also equal to negative 6 kilonewtons. And then for F3, it has both an x and y component. So this happens to be the x component, that is F3x, and then this, the y component, F3y. So for F3x is equal to, we have this small slope triangle. Now 3 corresponds to F3x, so that becomes 3 over 5 times 5, and that is equal to 3 kilonewtons. And then for F3y, it is equal to, it corresponds to 4, so 4 divided by 5 times 5, and that is equal to 4 kilonewtons. Now because F3y is acting vertically downwards, it has a negative value, and then because F3x is acting to the right or along the positive x-axis, it still becomes positive. Next, let's find the sum of Fx or Frx and the sum of Fry. So we have Frx to be equal to, for the x component, we have F1x, which is negative 8, and then F3x, which is 3. So that becomes negative 8 plus 3, and that is equal to negative 5 kilonewtons. And then for Fry, that is equal to, we have F2y, which is negative 6, and then F3y, which is negative 4. So that becomes negative 10 kilonewtons. Now let's find Fr. So that is equal to the square root of negative 5 square plus negative 10 square, and that is equal to 11.18 kilonewtons. Next, let's find the angle theta. So that is equal to tan inverse of Fry divided by Frx. Here we are going to neglect all negatives. So we have tan inverse of 10 over 5, and that is equal to 63.43 degrees. So that is the value of theta. So we have the equivalent resultant force to be Fr, which is 11.18 kilonewtons. Now we have the x component acting along the negative x-axis and the y component also acting along the negative y-axis. So we are going to have our diagram to be like this. So this is Frx, Fry, and this becomes Fr, and we have this to be the angle theta. Now at this point, we are going to specify the distance where the resultant force line of action intersects the member AB measured from A. So first of all, let's find the moments of all the individual forces about A and then sum them up. So that is giving us summation of MA, and that is equal to, now we are going to consider the forces 8 kilonewtons, 6 kilonewtons, F3y, and then F3x. So taking the moment of 8 kilonewtons about A, we have the perpendicular distance to be 3 meters, and then it is moving in the anticlockwise direction. So anticlockwise means that we are going to have this value to be negative. So negative 8 times perpendicular distance 3. Now let's move on to 6 kilonewtons. Now the perpendicular distance away from the line of action of A is 0.5 meters, and this is moving in the clockwise direction. So it's going to be positive 6 times 0.5. Now let's move on to F3y. Now F3y is equal to 4. We are going to use the positive value, so 4. So if F3y is 4, the perpendicular distance away from A, or the line of action of A, is 0.5 plus 1.5, which is 2 meters. So since we are moving in the clockwise direction, then we have a positive value, which is 4, times perpendicular distance 2. Now we move on to F3x. Now F3x is also going to move or act in the clockwise direction. We have F3x to be 3 kilonewtons, and the perpendicular distance away from the line of action of A is going to be 0.5 plus 0.5 plus 3, which is 4. Therefore we have 3 times 4. Now let's simplify this. So negative 8 times 3 is negative 24, plus 6 times half is 3, 4 times 2 is 8, 3 times 4 is 12. So 8 plus 12 is 20, plus 3 is 23, plus negative 24 is negative 1. So that is the summation of MA. Next, let's find the moment of the resultant force about point A. So for the resultant force, we are going to specify an arbitrary distance, say D. An arbitrary distance, say D, from point A. And that is where we are going to have the resultant force. And notice that we are to specify that point D away from A along the line AB. So we have the X component to be negative. So we are going to move along this line. Y component also to be negative, also along this line. And then we have this to be FR. So FR, Y, and then FRX. So we are going to find the moment using FRX and then FRY. So we have the moment or the resultant moment about point A to be equal to, now FRY is passing through the line of action of A, so the moment about A is 0. Now let's focus on FRX. Now for FRX is equal to negative 5. So we are going to use the positive value, which is 5, and then we are going to take the anticlockwise direction. So that's going to be negative. So negative 5 times perpendicular distance D. Notice that this is in kilonewton meter, and this is also in kilonewton meter. Now we are going to equate these two. So we have MR of A equals summation of MA. So that's equal to negative 5D equals negative 1. We divide through by negative 5 by negative 5, and then we have D to to be equal to 0.2. So that is 0.2 meters.